In this video, we're going to take a look at adding and subtracting rational expressions, which is related to our multiplication and division, but it's going to go back to some previous rules that we saw in earlier years, fifth or sixth grade, to where to add and subtract, we have to have common denominators. So I have some steps listed here for you, walking you through the process. It's a 7-step process. It does involve some factoring, so we're going to practice some of our factoring skills today, and we're going to get common denominators today and pull back some previous skills. So if at any point I go too fast, just pause the video, rewind it, and go back. Let me walk you through a few examples here. So let's see. Let's look at number one. We have two fractions, and that's what we're going to see in every scenario today. Two fractions, and we are going to either add or subtract based on what we see and try to simplify in the end. So number one, this is one of those basic ones that we saw back in elementary school where we have 11 over 10 minus 4 over 5. And the first thing we recognize is we cannot subtract these because they don't have the same denominator, right? If we look at this scenario, we have 10 as our first denominator and a totally different one after that, a 5. So because these two values do not match, we cannot subtract yet. But remember, we had strategies to fix that, and that involved multiplication. So knowing our multiplication facts helps sometimes in a scenario like this one, and realizing that 5 is a factor of 10. And if we were able to multiply 5 by a value of 2, 5 times 2 is going to give us 10 as our denominator in this second fraction. That's what we're trying to figure out here. So we're trying to figure out what value could be in both denominators through multiplication. And in this scenario, that's the value of 10. Also remember, when you multiply part of a fraction by a new value, the other part of the fraction must also be multiplied by that value. All right, so once we figure that out, we know what we're going to do here. We're going to rewrite each fraction. So, we'll copy down what we get. The first fraction is not going to change. We didn't do anything to that. But your second fraction will. Second fraction, 4 times 2 is 8, and 5 times 2 is 10. And that's the part we needed, okay? That's the part we needed right there, is those two numbers to match. So a couple things, let me take note of that here. For LCD, that's what I'm listing over here. That stands for least common denominator. Okay, so least common denominator, that's what we're looking for. What's going to make the denominators say the same thing? Okay, that's this part. Change that to blue. Okay. But now that your fractions have the same number underneath them, we have a 10 in both places. When you bring these two fractions together, let's remember how adding and subtracting works. The denominator stays the same, okay? So the denominator stays the same. Take a little note on that too. So the denominator is the same. Okay. And when we bring these together, we'll use the operation that's there. So for this operation, we have 11 in the first fraction minus 8 in our second fraction. And what we're going to do from here is we are going to subtract in that numerator. So your numerator, you have 11 minus 8, quick calculation, gives us 3. Denominator still is 10. And the last thing we ask ourselves, can 3 and 10 reduce? Maybe you already hear yourself saying no to that question, but you can also type these in, check that yourself, and you'll see there's no reducing of those values. Okay, so that is in a nutshell what we need to be able to do to add and subtract our fractions. Now, it does get a little more complex than that, but those are the ideas. We need a common denominator. We'll bring the fractions together where the denominator stays the same, and we need to either add or subtract in the numerator of our fraction. So let's see what that looks like when we add in a variable here. Now, 2, it looks more complex than number 1, and in fact it is. There is more to it, but if you're looking closely at these two fractions right here, you'll see right away they both have the same denominator of z minus 3. That tells me right away that my denominators already match. Both fractions have the same denominator. That is our least common denominator. There's nothing we need to do here. But since those two denominators are the same, we get to bring their fractions together. So we're going to bring our two fractions together. Z minus 3 is our denominator. Okay, what I'm going to do here is I'm going to write the two numerators separately. The first one is 5z, and I'm going to group those together. So we'll see 5z come down from our first fraction, and then I'll look at the operation in the middle. In the middle of this fraction, between the two fractions, we do have a plus sign. So we're going to put a plus in between here. After that, we have a second fraction whose numerator is 2z minus 21. I'll use grouping symbols for that too. Okay. So now what we need to ask ourselves is, a lot like in the last one, how do I bring this numerator together? Well, adding polynomials is actually a pretty basic process. One thing we can realize is there are values in front of these parentheses. We can put a 1 in front of them, but those are positive ones. And a 1 times a 5 is still 5. And 1 times a 2, still 2. So multiplying by a positive 1 does not change anything. When you are adding two polynomials, you can actually just write the expressions without those parentheses. So that's my next step here. When we're adding, the two parentheses are not needed. So we'll rewrite this as 5z plus 2z minus 21. All right. So now we have that. The only thing left for us is to check what values can we bring together. And those like terms, remember, are all decided on what numbers have a variable with them. So we have a 5z and a 2z. These two values can be combined because they both, excuse me, they both have the same variable here. So we're going to combine 5z and 2z, and that's going to give us 7z minus 21. So 5z and 2z, 7z for those. The minus 21, it's still there. We just can't do anything to it at this point. So we'll keep the minus 21, and that's all over z minus 3. That is adding and subtracting with variables involved. This is perfect. Now, the last thing we have to ask ourselves is, can we reduce? That's always the question. We asked it on the last one. Can we reduce 3 and 10? The answer is no. And we've done some practicing here of try to reduce, okay? So this is step 6. You finally added everything. The question in step 6 is, can you factor the numerator? And that's what we're trying to check now. Let's go down to our numerator here. It has a 7z minus a 21. 7z minus 21, those are two values that are divisible by the same factor. If we look at 7 and 21 and think carefully, we might realize they are both divisible by 7. Okay? What that's going to allow us to do is we get to take this fraction here. We're going to factor this numerator. And when we factor the numerator, instead of leaving it as 7z minus 21, we're saying we can divide a 7 away from this expression. And when we do, 7z divided by 7 is z. Negative 21 divided by 7 is negative 3. Our denominator, you might remember, already says z minus 3. And once we factor, what we see is there is something they have in common. And so when we see those commonalities, we get to reduce. And that is the goal. We are reducing away those parts they have in common. And when we do, we look at what's remaining. That is 7 over 1. And 7 over 1 is really just 7. So final result of this one, value of 7. So adding and subtracting is the main goal. That's the primary goal. After that, though, we do want to try to factor our numerator and see if something can cancel away. Okay, let's take a look then at number 3. It's very similar to number 2. If you're looking at this one, same idea. We have an x plus 6 in two places. Okay, so both denominators already have the same expression. That tells me right away that's my least common denominator. They are already in common. There's nothing else we need to do. We are allowed to bring the two fractions together then to where the first, to where when we combine them, the denominator stays the same. Now, when we bring them together, I'm going to group my two numerators, okay? So the first fraction had 3x squared minus 4. I'll put that here, my first grouping symbols, 3x squared minus 4. And then the second, we have a minus sign this time. So check that out. Be very careful with your symbols. Minus is going to be a slightly different process, okay? But the next numerator will group as well. So we'll group the 2x squared plus 32. And now all our job is, can we combine our numerator, okay? Now with this minus sign, we want to be careful with this. This is a minus 1. And let's think about what multiplying by negative 1 is going to do. Um, in front of the first set of parentheses, we could put a positive 1 in front of them. But remember, multiplying by positive 1 doesn't change anything. 1 times 3 is 3. 1 times negative 4, still negative 4. We don't need to worry about the first factor. But that second set is going to change. So what I'm going to do is I'm going to get this ready to show what our result will be. The first numerator won't change for us here. There's nothing there in front of it. But our second numerator will, because we have a negative 1 that we're going to distribute into these parentheses. And negative 1 times 2 is going to switch the sign. Now it's a negative 2x squared. Same thing after that. It's negative 1 times 32. And a negative 1 times 32 is negative 32. That's what we have to watch for when we distribute negative 1. Okay? We need to distribute that negative 1, and it's going to change those signs. So it's almost the exact same as adding, except we have to watch for that negative 1 there. Denominator still says x plus 6. Now that you've distributed, we're just going back into combining like terms. So as we look at your like terms here, there's a couple things. We've got 3x squared and a minus 2x squared. Okay, so when we look at 3x squared here and minus 2x squared here, we can think about what that's going to give us. So let's go ahead, set up a space for that. 3x squared minus 2x squared is 1x squared. Adding and subtracting does not change our exponents. Looking past that, we see also that we have a negative 4 and a negative 32. So negative 4 minus 32 is what we see. If you're not sure what that is, you can type it in to your calculator, negative 4, negative 32. So typing in exactly what's on in the top of our fraction here, negative 4, negative 32, we see that gives us negative 36. And it's very important that we pay attention to these signs because we're going to use these to hopefully reduce our fraction. And if we don't have the correct values, it's not going to reduce like it's supposed to. Okay, and then underneath we still have x plus 6. Oh, and I just caught my own error. You probably caught it too. It was a negative 36. I looked at the problem above and forgot to write down what it gave me. So negative 36. Okay. So this is great. We've added the two fractions. We combined everything we can. But remember, what we're going to try to do after this is simplify and reduce. So the next thing we're going to try is we are going to try to factor this numerator. So we're going to try to factor here, and hopefully that's going to allow us to reduce our fraction. So let's think about how we can factor something like x squared minus 36. For x squared minus 36, this is the difference of two perfect squares where we have two values we know the square root of and we have minus in between. And so we ask ourselves, what's the square root of x squared? Just x. What's the square root of 36? It's just 6. And after that point, your factors are going to use those values to where they both begin with x. They both end with a 6. But one will have a plus, one has a minus. So if we look at our numerator here, that tells me that I'm allowed to rewrite this as x plus a 6 and x minus 6, which is helpful because our denominator already said x plus 6. So based on that fact right there, we're going to try to do is reduce this, okay? And so we get x plus 6's are going to reduce. That leaves us with x minus 6 in our numerator. These reduce down to 1. And since we're left with x minus 6 over 1, that gives us a final result of just x minus 6. So again, we need common denominators to combine fractions. That's been true for all of our examples so far. With this minus piece, the only thing different was we needed to distribute that -1. After that, it's combining like terms to simplify your numerator, factoring, finding if anything can reduce, and then writing that reduced result. Okay, so our last example here is slightly different, and that's only because the denominators do not match right away. Okay, so here's what we're going to do. This is actually the very first step I listed at the beginning. Step one to all of this is factor all denominators. What that's going to do is allow us to compare what is underneath each fraction. So let's look at your x squared plus 2x minus 8. This expression has three terms. It's a trinomial. So we're going to factor this through our split the middle process. We've been using our x chart in here to where in the top of our x, we're going to use -8. And underneath that, we're going to have a +2. And remember, we need to multiply to that -8, but add to that 2 underneath it. So let's think this through. We need to multiply to a -8. So that means I need one positive number and one negative number. That's the only way this would work. And so in terms of things that can multiply to 8, that's either 1 times 8 or 2 times 4. And if we use a +4 and a -2, 4 times -2 is -8, and 4 minus 2 gives us that +2 that we need. So that's going to allow me to rewrite this denominator here as two factors, x plus 4 and x minus 2. So I'm not going to look at the original denominator anymore. I'm going to look at the x plus 4 and the x minus 2. And what I can do now is I can compare this to the second denominator and ask myself, what's missing? Because our first denominator has two factors, our second only has one. And what you might notice is they both have x plus 4, but one of them has x minus 2 and the other does not. So just like we said earlier in example 1, when they didn't match, we multiplied by a value to make the denominators be the same. We're going to do the same thing here. If our second fraction is missing a factor, we're going to add that factor in. So it already has an x plus 4. Let's give it the x minus 2. That way, both fractions will have the same factors underneath. And remember, if we multiply part of our fraction, we have to multiply both parts of our fraction by that value. So our common denominator is actually made up of two factors. There's an x plus 4 and an x minus 2. Now that we have that, we can bring our two fractions together. So let's go ahead and do that. Let's bring the fractions together here. That's going to give us x plus 4 and x minus 2 underneath as our denominator. There's our common denominator. In the numerator, we have two things. We have a 3x plus 18 from our first fraction. Okay, we also have a plus sign in between. So our first numerator was 3x plus 18. We have a plus in between that we need to watch. Okay, so we're thinking about how do we add in these scenarios. And then after that, we have a couple things here. We have a 1 with x minus 2 multiplying to it. So down here, after that, we'll keep the 1, and we'll write the x minus 2. Okay, so we need to simplify this numerator. Let's think about what we can do about that numerator. First off, just like in each of the previous scenarios, the first numerator doesn't change. You actually don't need those parentheses here. The second, we just need to distribute. So we have a +1 here, a +1. If we distribute in, +1 times x is plus 1x. +1 times -2 is a -2. All right, so we distributed. There's no more parentheses in our numerator. Our denominator still says x plus 4 and x minus 2. We never want to multiply this denominator together because we're hoping something might cancel when we're finished. Okay, so we're going to combine these like terms here in our numerator. So let's go ahead and set that up. We have a couple of values with x. So we have a 3x and a 1x. So we're thinking through, okay, 3x plus 1x If we add those together, that's going to give us 4x. So combining like terms here, 3x plus 1x is a 4x. After that, we look at the other values that are present. We have a positive 18 minus a 2, and plus 18 minus 2 is positive 16. 18 minus 2 is 16. Our denominator has x plus 2 and x plus 4 and x minus 2. And there you have it. We have combined our fractions. We've simplified that numerator down. Now, we still have these parentheses in our denominator, so we are still trying to figure out, can this fraction reduce? And this is another one of those scenarios to where we can factor our numerator. So let's factor one last time here. Okay, so factoring the numerator, we have a 4x plus 16. And it's a scenario like we saw previously in example 2. 4x plus 16, those quantities can both be divided by 4. And so if we factor this 4 from the expression, 4x divided by 4 is 1x, and 16 divided by 4 is 4, which is great because that gives us 4 times the quantity x plus 4. Underneath that, we have our two factors from before, x plus 4 and x minus 2. And you might notice from there, what we needed to happen has occurred. We have x plus 4 in two places. So we get to reduce this fraction. We'll keep what we were not able to cancel. So as our final result, we have 4 in our numerator and x minus 2 in our denominator. Since it's the only thing there, no more parentheses needed. And that is our reduced expression. So walk yourself back through these steps. Use these examples to guide you as you practice. That's our goal for today. When we move on into our next lesson, we'll be looking at fractions to where we might need to multiply both fractions to get that common denominator.